I feel like I should be like, sorry, I didn't record. Just pause. Take a minute. Copy it down. All right. You guys were here. So even and odd trig functions, again, you can find them the same way we found even and odd or neither with our other functions. So what that means is you plug in negative x, and then depending on what you get, you have an even or odd. So if you plug in a negative x to cosine, you will always get what's equal to its positive x. If you plug in a negative x to sine, you will get negative sine x. So, for example, if I looked at x equals pi fourths, that's an easy one, everybody always knows it. If you do the cosine of negative pi fourths, that is equal to the cosine in quadrant 4. Cosine in quadrant 4 is positive root 2 over 2. If you compare that to the cosine of pi fourths, it is also positive root 2 over 2. Now, similarly, the sine of negative pi fourths is equal to negative root 2 over 2, and negative sine of pi fourths is negative root 2 over 2. The sine of pi fourths is positive, but then you multiply by a negative. So that's kind of how you could look at the even or odd with an actual value on the unit circle. So we kind of briefly talked about the transformations of trig functions. I told you that their transformations are exactly the same as the transformations of quadratics. No, we are not going to be graphing trig functions like I had initially anticipated, because like I said, just not something that's really on the AP exam anymore. The value in front will do the stretching or compressing. The B value will move it left or right, as well as horizontally stretch or compress it. And then the D value is the movement up or down. So when we're trying to find the period of a trig function, you distribute that b to the x, and you set bx equal to 2 pi or pi, depending on the trig function. So 2 pi for sine, cosine, cosecant, secant, pi for tan, cotan, because they have shorter cycles to begin with. They don't sell Gatorade at the cafeteria, do they? I hardly ever go in there. Mm-hmm. Okay. So like I said, we're just going to skip it. I'll walk you through it a little if you want to talk about the numbers on it. The negative is your reflection. The 2 will stretch my graph. It's going to make it more narrow. The 4 is going to shrink the period. So what that means is this is going to occur faster. So instead of the period being 2 pi, my period is now pi halves. It has a horizontal transformation of -5/4, so it's shifted left 5/4. So for the horizontal transformation, you set everything inside the parentheses equal to 0 and solve. And then vertical is none. So like I said, we're not really going to graph, but knowing how the graph moves is somewhat important. Just so you have an idea of domain or range in terms of the inverse. None of the 6 basic trig functions graphed are one-to-one. So we talked about that already with inverse trig functions. Therefore, what we have to do is restrict their domains. So in each of the cases, when we talk about trig functions and their inverses, we restrict their domains. We saw that last night on the homework when we got our answers to the arc trig functions. So what I did was give you a table to fill in with each of the restrictions. So inverse cosine has a domain that was its range. So the range of the sine and cosine graphs are 1 to -1. So that range now becomes your domain. To make the graph 1-to-1, we have to restrict it. So cosine will be 0 to pi. So what it means is the graph of cosine from 0 to pi will be 1-to-1. Sine, we go -pi/2 to pi/2. Tangent is -pi/2 to pi/2. And then secant and cosecant match their partners. So like secant 0 to pi, cosecant's -pi/2 to pi/2. Cotangent is the only one that doesn't match. So tangent and cotangent are unique. Cotangent is 0 to pi. And that's because it's cosine over sine, so it follows cosine. This is what their inverses look like graphed. They're kind of like goofy, but that's how they become 1-to-1. Okay. So sine inverse of -1/2. Technically, you could see it as occurring in either of these quadrants, but if we talk about its restricted domain, then we know that only one of those answers in actuality. So this is if it was occurring on 0 to 2 pi. If you talk about the arc and its inverse in terms of actual trig, then we have to say that it is -pi/6 because of the values of arc sine. So technically the sine is -1/2 in quadrants 3 and 4, but when we talk about the inverse and its restricted domain, your calculator is going to output this value, which is really this. If you're in degrees, it's going to output -30. So when we talk about the arcs and the sines, we have to make sure they live in the right quadrants. So again, arc cosine answers are going to come in here, and arc sine and arc tan are going to happen here, and these are going to be negative trig values, meaning with negative radians. So let's use the inverse trig on our calculator. Now again, this is where I was talking the difference between the two. This one has an open range from 0 to 2 pi. Whereas if it's just talking about the inverse, it's different. So this is an open 0 to 2 pi. So how many answers am I going to have for this one? 2. This one has 2 answers because this isn't the inverse sign. That's the difference. It's saying, okay, when does the sine of x equal 0.7 on the unit circle? So now we're talking in this zone. So you go, make sure your mode is in radian. Second sine, so you get the sine inverse on here, 0.7. So 0.7753 is in quadrant 1. Because again, remember the bounds are 0, 1.57, 3.14. I forget my bottom, 4.71. Yeah, I just did that right now. I remember if it was 4.71 or 4.52. Okay. So, sine is positive in quadrant 1, and what other quadrant? 2. So that means one angle lives here, so the other angle lives here. So to find the other angle, I'm going to take pi minus x, which is 0.753, and get my answer. So you take pi minus that 7753 number, and we get 2.366. Those are the only 2 values with which this can occur from 0 to 2 pi. Now, tangent has an infinite domain. So now we need to account for the fact that this is going to occur over and over and over, because tangent occurs over and over and over. So the tangent of x equals -2 means we want to take the inverse tan of -2 and find the first time this happens. And it happens at -1.107. To figure out where that is on our unit circle, you add 2 pi to that number. So you get 5.176. 5.176 is going to live in what quadrant? 4. And that should make sense that this first answer was negative, because arc sine on our calculator can only produce answers from 1 or 4. Sine and tangent are both negative in quadrant 4. So tangent repeats every 180 degrees. So if we want our answers to occur every 180 degrees, we're going to take that -1.107 and add pi k to it. And what that's going to do is just keep moving it around and around and around, but making the points occur here, then here, here, then here, as it keeps traveling around the unit circle. So you could like subtract pi, and you'd get 2.0344, which would put it in quadrant 2. If you subtracted pi again, you'd end up back in quadrant 4, and you could keep doing that, and you could keep traveling around. So this is how we account for an infinite domain. So let me confirm those homework problems. Okay. 11:14C, yeah, that's some of the graphing. So we're going to change this. We're going to pause.